Grand finale. So now we have our programming environment set up and we have installed all the packages that we need. It's time to actually reproduce the work that is in the repo. So as I said, the treat repo is not really a full-blown research project. It's more like a template that you can use to build your own research projects. And what I want you to focus on here is I want you to focus on the steps that we take in order to reproduce the analysis that is contained in this repository. You will see that once we've set everything up, and we have set everything up, that the actual steps are relatively easy and take time, but not our time, but just the processing time of the computer. Okay, so you see the README here, and the README has these steps that we want the user, the fellow researcher, to follow in order to reproduce our work. So the first step we did already, right? So we cloned the repository to our local environment. And then we also did the second step. We had all the packages being built. And now comes the third step. We have to config and the environment. And here in this case, that means we have to enter our WRDS access data. So for this, we have this config file that the user needs to edit. I think it's good policy to have the important things that users need to edit in a separate file and not somewhere hidden in code, because people that are a little bit unfamiliar with coding, maybe they are reluctant to make changes to your code files, right? So here, in this case, this is also important for another reason. Obviously, we don't want our WRDS password to end up on GitHub, or we want to keep it private. And this we can do with this little trick. We have this config file and we save it without the underscore. So I'm not saving it here because I already made my changes. And then this config file without the underscore will have our private WRDS login data, but it's not been committed to Git because it's in gitignore, and we can run based on this information. So with the private file being contained in the root directory, and without actually making the data available for anybody. So now you see our output folder, it's empty, and we hit build. So build is where the make file comes into play. So I'm not showing you the make file here, maybe I want to do a special video on this, but this make file is the file that actually does the trick that starts to knit all these files together. So it monitors all the dependencies, and this make file here starts the first script, and the first script is called pull WRDS data. And what it does is, well, it pulls WRDS data. So it logs into the WRDS server and pulls some CompuStat data. So CompuStat is provides North American financial accounting data for publicly listed firms. So I speeded this up a little bit, but it takes a few minutes in real time because it's a bunch of data that is being downloaded. And now you see it's done, right? So it has downloaded the data, and now the next step prepares the data. So you see, speaking file names are always helpful. Prepare data calculates certain accrual measures and stores these accrual measures in a raw data file. So this also takes a few seconds, depending on your computer speed. It might take a minute or so. And now the next step does the analysis. You see, do analysis actually does what it's supposed to do, right? It estimates a bunch of models, produces some figures and some tables, and then all these results are then being stored eventually in the output folder. You see the output folder in the lower right, and you see, I can't talk to you because I don't have to do anything. I just hit make. So here are our results. You see, results RDA is a R data format where you can save several data frames at once, and now results contains all our results. And in the meantime, another process started, and this process is our markdown process, and this actually knits our paper. So in the folder, in the doc directory, you will find a little bit of Markdown code. Markdown is a very simple text-based formatting code. And this contains our paper. Well, not really a paper, as you will see in a second, just a stub. But this paper is now being automatically created. And now what you see here is also something that I like. You see we have this very fresh tech install, right? So we did it in the last video. And it has no packages whatsoever. And our paper, of course, like every LaTeX project, uses several packages from LaTeX, and these are now all automatically being downloaded as we speak, and now these they are installed to our own tech environment. You can see this here, and while this takes a while when you do it for the first time, you only have to do it once, right? Then the packages are being installed, and with the packages installed, they of course the process will run much quicker the next time around. So this is something that I think is really great for reproducible work. So you see that we have several files here that are connected to each other, and I encourage you to take a good look at the GitHub repo in order to see the actual files and how they depend. So in essence, we had one file, a download or pull WRDS data. Then we have the next file that actually uses this data to calculate some measures, prepare data. Then we have one file, again, all these are R codes that run the actual analysis and produce this output file that contains all the data items around the results. And then we have two markdown files. So you're currently seeing the first one. The first markdown file results in a paper. Yeah, so and the second markdown file will result in a presentation. And all of these files are combined by a make file that describes all these dependencies. Okay, and these dependencies are important because this tells R or whatever software package what to do if let's say a certain file is being changed. Yeah, so then the make file will check which files depend on the changed file and only create these new files that need to be changed. This is really convenient in large projects, and also it makes everything relatively easy because here you see that we don't have to think about the order in which the files need to be run. We don't have to do this step by step our own. We can trust Make to do it, right? So Make does it for us. And you see that in the meantime, the paper has been produced, right? So you see in the output folder, now we not only have the results, but also a paper, a PDF file, right? So it has been produced by us. We reproduced the paper. Now, you see that here we also have a presentation. So now the next file has been knitted and transformed into a wonderful presentation. So now we can, of course, take a look at these. And so we're going to start with the presentation maybe. So here we go. So this is our wonderful new Beamer template that we use for our research corporation, Accounting for Transparency. And you see that here, yeah, well, it looks like a typical academic presentation. Yeah, so it has fancy graphs about these measures that we calculated. And then, of course, it also contains tables, because who doesn't like tables? So tables need to be there. And the great thing here is that all this is basically a combination of code and the text that we need to prepare the markdowns, right? So the actual presentations and the paper. So whenever something is changed, we simply have to rerun Make, and then we will create the new paper and the new presentation with the new data. Yeah, maybe I'm going to show you this in another video. So if you don't believe me, but for us, this, of course, as researchers, this is super convenient. So how many times have you redone tables? Because you changed an aspect of the analysis. With this workflow, you don't have to do it anymore. So once you set this up correctly, and you change something in the analysis, the only thing that you will have to do is you have to remake your analysis. and then you're gonna have a wonderful new paper and a new presentation and all the other outlets that you can think about. So this is it. So, and to show you that only the thing that is really needed is being redone, I just clicked build all again. So build all took a few minutes the first time around, but now you've seen that it took just less than a second, and saying, okay, I don't have anything to do, nothing to do. You're all up to date. So the code has been built. Wonderful. So this concludes our little video series. I hope that it motivates you to follow along and to install your own little computing environment if you haven't done so already, and to use this project template, the tree template, for your own projects. Yeah? So the basic idea is clone it and throw away everything that you don't need, and start coding along and modify and change. And if there's something you don't like in the repo, please by all means get in touch. You know, issue a pull request to our repository. You know, maybe you want to contribute. Maybe so we are trying to develop this into a more statistical programming flexible repository. So we would like to have also Python around, and maybe even Stata, so that people can choose the statistical programming language that they want for their projects, so that this becomes over time maybe, you know, just a one-stop repository that you can simply clone whenever you start a project, and it saves you some of the setup time that you normally always have. And yeah, and that's all. That's the idea of it. So please, if you have any comments about all this, you know, you can also leave it here on YouTube, or you can contact us via Twitter or email, and we would be very happy to hear from you. Thanks. Cheers. Bye-bye.